All right. Hello, aloha, talofa, and hafade, and thank you to everyone joining us for our special program on sleep and dementia. Today we have folks joining us from Arizona, California, Hawaii, and other parts of the country, including the Pacific Island territories like Guam, the CNMI, American Samoa. So just a few housekeeping items. Before we begin, please use the Q&A feature located at the bottom of your screen to ask questions. Your camera and mic will stay muted for the duration of the program to help minimize any distraction and background noise. I apologize, there's construction being done in my building, so that's the background noise that you're probably hearing. This program is being recorded, and a link to the recording will be provided later this week. At this time, it's my pleasure to kick off today's program with a mission moment. Joining us as our mission speaker is Paula Gogin. Paula resides in the Bay Area and is a caregiver for her mother who lives with Alzheimer's disease. Professionally, Paula is a seasoned nonprofit professional who currently is the Director of Advancement at Lumen Christi Academy. I worked with Paula very closely during our time together at another nonprofit organization where she served as the Major Gifts Officer for the Western region of the United States. At this time, I'd like to turn it over to Paula, who will share with us today's mission moment. Paula?
Hello, everyone, and thank you, LJ, for inviting me to join you all today. As LJ mentioned, he and I worked together a couple of years ago, and while I was very sad when he left, I was happy to hear that he had joined the Alzheimer's Association, not only because it's a disease that affects me personally, but I knew that LJ could put his skills as a fundraiser and community advocate to amazing use. I'm here to tell you about my mom and her story with Alzheimer's. My mom, who lives in Southern California, will turn 90 in October and was diagnosed with the disease in her late 70s. I remember prior to her diagnosis, both my brother and my dad would comment about how much she was forgetting things and repeating questions to gather the same information over and over again. I didn't believe she had a problem until I too experienced her forgetfulness during one of my visits. About that time, my mom must have said something to her physician, and unbeknownst to all of us, was prescribed Aricept. I was at the house that weekend when all of a sudden she started to throw up. We later found out, after my dad noticed the medication in her drawer, that she was prescribed Aricept and that vomiting is a side effect. Needless to say, it was at that point my dad called the doctor's office and became involved with my mom's health care. As the years progressed, my dad would try all sorts of different homeopathic remedies to help with my mom's ever-increasing memory loss. The vitamins in combination with the Aricept, according to him, seemed to work. Regardless, I just knew the decline was slow, and every cold or infection seemed to send my mom further downward. In January of 2018, my dad's own physical health started to rapidly decline. I remember my brother and I thinking that our mother's lack of concern over his health was alarming, and we both knew we had to take charge. He passed away within a few short weeks, and she was more bothered by the remains of his hospital bed than by his absence. We now knew what my father had been dealing with, and his frustrations and sadness was now becoming our journey. Fortunately, my dad had left our mom in good financial shape. However, managing my mother's health care and caregivers was a huge responsibility for both of us. I felt like suddenly I had acquired a new child. However, this one liked her cocktail at 5, wine with dinner, and dessert, even when she didn't finish her dinner. Over the next 3 years, things got worse. Incontinence, poor nutrition, poor hygiene, refusal to take medications, phone calls day and night, etc., became the norm. And each week was fraught with a new challenge. And then COVID. I continued to travel often to see her, and my brother stopped by as well. She didn't understand the disease, so we did our best to explain it to her. We kept our fingers crossed that she wouldn't catch it, but COVID defies everything. And sure enough, in early January, amidst the height of California's COVID surge, our mom caught the virus from her most beloved caregiver. Faced with either putting her in the hospital where she wouldn't receive any care because of the impacted ERs, we made the decision to put her on hospice. She slept 24 hours a day, and the caregivers did their best to provide water and applesauce whenever she awoke. Amazingly, she recovered, but is now bedbound, and her memory has been completely damaged. In light of her decline, on March 15th, we relocated her to a residential care home for better care. That first week was one of the most stressful and awful weeks of my life. She didn't understand where she was, why she needed to be there, and continued to have people call my brother and I, crying and begging to go home. Fortunately, I'm happy to report that 2.5 weeks later, she's adjusted. But going through that week was so emotional for everyone. As anyone who has a loved one affected by Alzheimer's, we know the day will come when our parents don't know who we are, and I dread that day. I do so much for her out of guilt and duty, knowing that there really is no reward. The decline is painful to watch, and the mom I once knew is gone. She can't comprehend my personal struggles or provide guidance on my challenges. She is, as I once told someone, this nice lady who I am responsible for. I am grateful to the Alzheimer's Association for your work, not only for my mom, but for me and my children and my grandchildren, because I know if something isn't done, the disease will take one of us as well. I look forward to staying involved in the fight, and thank you for your good work. The lives of millions of Americans depend on you, and I pray and hope for your success. Thank you so much, and it's just a joy to be with you today.
Well, thank you so much for sharing your story with us, Paula. Stories like yours keep us motivated to find and keep pursuing our vision of a world without Alzheimer's and all other dementia. So today we're going to shed some light on some important topics, and I'm so pleased to welcome two fantastic presenters today to illuminate some topics around sleep, aging, and memory. Topics that there's so much interest around in the public today. Our first presenter, Dr. Steven Cowen, is an associate professor in the Department of Psychology at the University of Arizona. His research seeks to understand how neural activity is coordinated as we learn, decide, and sleep, and how this coordination is affected by normal aging and Parkinson's disease. His research team is currently investigating the function of the hippocampus, a brain region involved in memory formation and navigation. Dr. Cowen was born and raised in Fredonia, a small town about 30 miles north of Milwaukee, Wisconsin. After high school, he went to the University of Wisconsin-Madison, where he received a degree in business management. After graduation, he joined the Peace Corps and served in Honduras for 2 years as a micro-business consultant. It was during his time in Honduras that he decided to study the mind and brain. This decision ultimately led him to graduate school at the University of Arizona, a postdoc at the Neurosciences Institute in San Diego, and a professorship at the University of Arizona. So glad to have Dr. Cowen with us today. And our second presenter will be sharing information about the 10 warning signs of Alzheimer's. Steve Tam was a caregiver for his late father who had Alzheimer's disease and has 3 uncles who now have Alzheimer's. Steve retired from the Alzheimer's Association in 2020, where he was the director of development and led the Aloha chapter's fundraising programs. He now volunteers as a community educator and serves as a sponsorship chair for the Oahu Walk to End Alzheimer's. Steve, previously the manager at Bright Star Care of Honolulu, that provided in-home caregiving for individuals with dementia and other disabilities. Prior to that, Steve worked at AARP Hawaii as a director of advocacy and led campaigns on long-term care, Medicare, Social Security, caregiving, and financial security for seniors. Steve also worked at Prudential Locations Real Estate as vice president of sales and broker in charge. Thanks to both of our presenters for joining us today. And as LJ mentioned, we will have time for questions and answers after each presenter. So if you have questions throughout the session, please use that Q&A feature. So without further ado, I will turn it over to Dr. Cowen.
All right. Hello, everybody, and thank you for the invitation. This is very exciting. Can everybody just give me a thumbs up as you can hear me fine? Everything's good? All right. Just want to make sure before I start. Great. Okay. Well, again, my name is Steven Cowen. I'm here at the University of Arizona in Tucson, Arizona. And I'm a scientist. I study the brain from a number of different perspectives and very interested in topics like learning and memory and Parkinson's disease and aging. And today I'll focus a bit on our research investigating sleep. But before we get into our work, I want to go ahead and first turn on the chat just to make sure I'm not missing anything and any messages, because I don't want to. Oh, good, great. Just making sure I got the good. All right. Zoom. So I'm still getting the hang of this thing. All right. So to get you situated to where I am physically, I study the hippocampus. So location is very important to me. I live in Tucson, Arizona. My wife and I live near the outskirts of town, a beautiful area near Sabino Canyon. So if you come to Tucson, Arizona, I highly recommend you take a hike in Sabino Canyon. It's a beautiful area. I woke up about a month ago to come up with a surprise. I looked out the window and this is what I saw. Yeah, just less than a month ago, we had a bit of a snowstorm in the middle of the desert. It was pretty exciting. Yeah, it was gone by noon, but perhaps those of you out there in Hawaii and Micronesia and Guam might appreciate that. And another benefit of living in the desert is we get a lot of visitors. So my wife actually took this wonderful photo of some bobcats in our backyard. So this is where I live. Where I work is here. So I'll put on a little pointer here, the laser pointer. So this is Tucson. This is the University of Arizona campus. And my lab is right around here. It's in the hospital facility. And I come to the lab almost every day, and I get to work with these wonderful people. These are some of the graduate students, undergraduate students, and graduated students that have worked in my lab and make everything really happen. So I'm very fortunate to have such an incredible crew of people I get to interact with on a daily basis to do the research that we do. And what we all are interested in the lab broadly can boil down to how neurons communicate with each other, how they can form connections with one another, and how all of that supports learning and memory. And this is, of course, a very hard question. And to illustrate how hard of a question that is, let me just play this, what sounds like a staticky noise, piece of noise in the background. What you're listening to is the activity of a single neuron in the hippocampus of a rat. Whoops, let me back up again. Now, the hippocampus is an area that we think is very important for learning and memory and spatial navigation. And that was one neuron from that region of the brain. It was just firing away, sending signals. Now imagine each of you, all of us, we have over 80 billion neurons in our brain, and they're all doing something like you just heard. Now, to do meaningful things like learn, act, move, remember, we need to coordinate, our brains somehow need to coordinate the activities of those neurons so that those abilities can actually happen. And so that's a big question. How do neurons coordinate their activity in space and time so that we can learn, decide, and remember? And so that's a core question that at least gets me out of bed in the morning to go to the lab. Now, we're interested in that question, but we're also interested in the issue of when that coordination goes wrong. So sometimes the coordination between neurons can be disrupted or affected negatively in conditions like Parkinson's disease, which we study in the lab, and also in normal aging, which we also study in the lab. And so we can talk about that perhaps in the Q&A, but we do a fair amount of research in the lab in Parkinson's disease and the role of dopamine in the brain. All right, getting back to organization and order in the brain. There are a number of theories in neuroscience as how the activities of those 80 billion neurons in our brains become coordinated and organized. But one of those theories, that's probably one of the more accepted ones, is that different brain rhythms, brain oscillations, which represent the activity of many, many neurons, kind of a macro a level of activity of many, many neurons at once that kind of wiggle or oscillate in time, help coordinate and organize and constrain the timing of individual cells. So you have these macro level fluctuations in voltage that restrict the timing of the activities of individual neurons in the brain. And that restriction is important because timing is everything in the brain. Timing is everything in life, but timing is everything in the brain especially. And I'll try to illustrate that with this example. So if you see up here, we have two neurons. I just illustrated a neuron with a little circle here to simplify a neuron. And the little traces here indicate the voltage pulses that the neurons emit when they're firing away in the brain. And so you have these two neurons, and they're emitting these little pulses we call spikes or action potentials. And if you want to get two neurons to form a connection with one another, to enhance the synaptic connectivity between those two neurons, you need to coordinate the timing of the two neurons. Let's call the first neuron neuron A and the second neuron B. If neuron A, oh, sorry, are you able to bring the slide forward? Can't read. Okay. Uh-oh. It looks like one, for some reason, the wrong screen is maybe not showing. All right, how about I actually, let's see, let me cancel or stop the presentation here, and I will physically apologize for that. I don't know why the other screen wasn't showing. I'm gonna switch to my only this screen. There we go. All right, I have two screens and I was probably jumping to my other computer screen for reasons unbeknownst to me. And now I'll force it to be on mine. Oh, okay, so it was fine. Oh, well, now I'm on a single screen anyway. All right, well, now I know it'll work, so no problems there. All right, so let me continue then. All right, so we have two neurons. I left off where we have two neurons in the brain. Neuron A and neuron B, and the activity of neuron A has to precede the activity of neuron B within 20 milliseconds of each other if those two neurons are going to form a connection. And so that timing, that's 0.02 seconds. That's a really, really small amount of time that the activity of these two cells needs to be coordinated with each other. So it's critical that timing in the brain is absolutely precise. And it's kind of surprising that the brain can even achieve any level of precision given the inherent noise in the activity of individual cells. So it's a mystery how it even occurs at all. In addition, the timing, if it's wrong, if it goes in the opposite direction where neuron B fires before neuron A, you can actually weaken a connection between cells. So again, timing in the brain is critical to its function. All right, so that gives you a little background as to why brain oscillations might be important for coordinating the activity of individual cells in the brain. Now I'm going to switch and talk about what those brain waves might do in sleep and memory, how they might help support memory as we sleep. And then I'll go into how they change as we get older. All right, so sleep first of all. Why do we sleep, period? There are many ideas as to why we sleep, and the answer is probably all of the above. One is to support immune function. We can get sick if we don't get enough sleep. Sleep is definitely important for supporting most immune functions in our bodies and our brains. It's key for emotional regulation, as you probably all know. If you don't get a good night's sleep, you're maybe not the most pleasant human being to be around. And it's important for what we call garbage collection. So getting rid of all the kind of detritus, extra proteins, oxidative stress, things that build up during the day that aren't good for our cells. Sleep is really good about helping getting that out of the body, out of the brain. I'll talk about that in a second. And then what our specialty in the lab is exploring the role that sleep plays in memory formation. All right, so before I go though, I want to take a little aside into Alzheimer's disease because although this isn't my area high expertise. This is something that's just fascinating to me. So in your brain, you have neurons, but you also have another class of cell called glial cells. And they're kind of like the support cells, the cells that keep your brain healthy, get rid of the oxidative stressors in the brain, help give nutrients to the individual neurons. But they also may be very important during sleep, because interestingly, in sleep, and especially slow wave, this deep sleep that we all have at night, these glial cells shrink. And when they shrink, they leave more space between the cells in the brain. And that extra space allows diffusion and a removal of amyloid proteins, the proteins that are associated with Alzheimer's disease that built up during the day. So sleep might be very important for the removal of these nasty proteins that can contribute to Alzheimer's disease. All right, how does sleep change as we get older? Well, a lot of us probably have already experienced much of this. We often have difficulty falling asleep. We get to bed earlier. Our depth of sleep is limited. We can easily be woken up. And related to this, our sleep is usually in shorter segments. It can be more fragmented. And we spend less time in these critical periods of sleep, these deep, dreamless sleep periods called slow wave sleep, and these more dream-related sleep called REM sleep. Actually, we do dream during slow wave sleep, but it's a different style of dream. And so we have less time in both of those stages of sleep as we get older. And interestingly, all of these effects above seem to affect men more than women on average. And these effects in healthy, normal aging, these effects you see above tend to level off at age 60 or so. And they might keep going up a little bit, but they don't get that much worse after that. Things do get worse in pathologies, especially things like Parkinson's disease and Alzheimer's disease, where many of these effects are exacerbated considerably. All right, now going back to the topic that we're really interested in the lab are these brain waves or brain oscillations and what they might do to support memory formation. All right, so there are three major brain waves that our lab studies, and most people in the scientific community think are critical for supporting our memories during sleep. They're called slow oscillations, from which slow wave sleep is named, spindle oscillations, which are timed with these slow oscillations, and the things that I'll talk about more today, these sharp wave ripple oscillations, which occur in the hippocampus and are also coordinated in time with the slow and spindle oscillations. All three of these brain waves, again, are organized in time, and their interactions appear to support the gradual integration of recent memories into your long-term memory store. And how this happens, we think, is this dance that neural activity plays between the region of the brain called the hippocampus down here, which is this little red blob there. It's about, if I put your fingers at your temples and pushed in about 1.5 inches, you'd be tickling your hippocampus. So it's an area deep in the sides of your brain. Here it is in blue at the bottom. And this area is critical, again, for memory formation, but also navigation through space. And that's where these sharp wave ripples are generated. The ripples can help trigger and organize the activities of these slow oscillations and spindles, and vice versa. The slow oscillations and spindles can help trigger and organize the activities of the ripples. And the information carried in these oscillations is thought to gradually become integrated in the cortex, this area at the surface of our brain, so that it supports and strengthens our long-term memories. And all of this is happening for free as we're sleeping. It's amazing. And so we get it when we're doing nothing. We're getting this long-term workhorse activity as we're in slow wave sleep to gradually strengthen our memories. All right, why do we think that these oscillations are important at all? Well, one, if you disrupt them through a number of mechanisms, like if you disrupt ripples in the brain by maybe putting a little electrical pulse at the time of a ripple, you can mess up memory. If you also get more of these ripple events, these fast oscillations in the hippocampus after new learning. And as I'll describe in a second, you get replay in these ripples of recent experience during sleep. And I'll show what I mean by that in a moment. And similarly, after new learning, you get more spindles and more of these slow waves, and you have longer periods of slow wave sleep. And this is the most exciting, although I would say the most controversial right now, is that some interventions like brain stimulation, either through transcranial magnetic stimulation or through auditory stimulation, may enhance slow wave sleep and spindle oscillations and increase memory. However, the original studies that did that, there have been recent studies that have failed to replicate those effects. I'm hoping that we can figure out why, because if we can, we may have a non-drug way of enhancing the depth of sleep, and that could very well improve all sorts of function, even memory and beyond. But currently, we need to figure out, the community, the scientific community needs to figure out why it seems to work in some conditions, but not others. Okay, getting back to what our lab really works on, at least for currently, and we work on a lot of things, but this is our one of our current research interests, and these are these ripples. Again, we get ripples, we have ripples, rats have ripples, all mammals that have been explored, every mammal, we actually measured activity in the hippocampus, we have seen these ripple events. And they're short, they only last 70 milliseconds, or up to like 100 milliseconds, 70 milliseconds, so like 0.1 of a second. Very short duration. And within that little window of activity, you see these little wiggles. And these little wiggles that are happening within a ripple are occurring at like 150 times a second. They're these super fast wiggles within a ripple. And neurons are, the brain cells are actually coordinating their activity to those fast ripples in the ripple. And I mentioned before that these ripple events, these little guys up here, are generated in the hippocampus of the brain. And here is, if you took a slice of the hippocampus, like around where the pointer is, and looked at it, it would look like this. All the different colors indicate the cell bodies of individual neurons in different regions of the hippocampus. The neuroanatomists have named these the dentate gyrus because it looks like a tooth. CA stands for cornu ammonis because they like Latin and stuff like that. It means ram's horn because the early anatomists thought the hippocampus looked like the horn of a ram. And this whole structure is so critical for memory and learning. And the region I'll talk about right now is this, what we call the CA1 region. That's where our electrodes are that we use to measure brain activity. And we measure brain activity, and if you look at that activity during a ripple oscillation, you see almost an explosion of activity in the hippocampus. Most of the neurons in the hippocampus become instantly active. This right here, this plot here, shows the activity of the neurons in a rat hippocampus aligned to the start of a ripple oscillation. And so you see this just explosion of brain activity, and then it quickly stops. And then you see a break, you might not have any activity for another second or two, and then bang, you'll get another one. And these are happening all the time as we sleep. And also, as we've learned more recently, they also occur during waking when we're zoning out. And they might serve some very important functions during waking as well. All right, so given our knowledge that ripples are important for memory, we asked the obvious question, like, well, how does this impacted by age? And so my colleagues and I, Carol Barnes's lab, who's a colleague of mine here in Arizona, her students and mine, we worked together to investigate how ripples change with age. And to do that, we put micro fine electrodes into the brain, in this case, the brain of rats. And those micro electrodes that are thinner than a human hair can measure the electrical pulses emitted by individual cells in the brain. And that allows us to actually measure the activity of individual neurons, but also measure these global macro oscillations, ripples and sharp waves and things like that in the brain. And the other beautiful thing about the hippocampus, in addition to having ripples and being important for memory, is that the neurons in the hippocampus express spatial or place-specific activity. So let's just say you plopped a bunch of electrodes in the hippocampus and were able to record the activities of electrodes in the hippocampus. And then if you're a rat, you're asked to explore a box, let's say, filled with chocolate sprinkles. And this is, I'm just describing a standard experiment people do with rats because they like to explore for anything, but they really like chocolate sprinkles. And if that rat is walking around a box, these little colored dots indicate the spikes or action potentials from individual cells, individual neurons in the hippocampus. And so you see one cell, it's called this big blue cell, that seems to fire when the rat is in the southwest corner of the box. This red neuron fires when he's in the middle of the box. This green neuron fires when he's in the northwest corner, and so on. And so if you look at the activity in the hippocampus, it forms a map of space, which is a really incredible thing, because also if you damage the hippocampus, your ability to navigate is severely impaired. So it seems to suggest that the hippocampus is helping us navigate by forming this cognitive mental map of the world. And that's handy as a neuroscientist, because as a rat explores, he goes through different sections of space and enters and leaves these different regions of activity, therefore activating different neurons in order. So let's imagine this purple field here is the field where one neuron is active, then this orange one is another neuron, and this green one is another neuron. So by just walking through the space, this rat can sequentially activate the purple neuron, then the orange neuron, and then the green neuron when he's looking for chocolate sprinkles. And that's a handy thing, because then what I can do is, during behavior, measure that activity, and then see if that same sequence of activity of purple neuron, orange neuron, green neuron repeats itself in subsequent sleep. And sure enough, what's amazing about the hippocampus is that if you look at brain activity in sleep, you see that these patterns of waking activity are repeated during sleep, as if you can see the brain replaying a past experience during sleep in real time in a moving, exploring, and then sleeping rat. All right. And if you measure that replay, the degree to which recent experience is rehearsed or reactivated during slow wave sleep and ripples in the hippocampus, you see it's reduced in aging, in just healthy, normal aging. These are 24-month-old rats. They're definitely old rats. They move like at half the speed of a young rat. They're pretty pokey, but they can do the task. And so you see a decline in replay. But I wouldn't get all depressed about that, because overall, older rats, like older humans who are old, in general, if it's healthy aging, you do pretty well on most cognitive tasks. Yeah, you might have a little decline in memory, some sleep issues, but for most cognitive behaviors in humans and rats, there's an amazing level of preservation in healthy, normal aging. Of course, all bets are off when you have a disease state, but in healthy, normal aging, in general, replay is maybe declined, but it's not by that much. And in general, cognitive performance declines, but in healthy aging, we have a lot of compensatory mechanisms in our brains and can keep us mentally healthy as we get older. Okay, but that said, our brain changes a lot. Our brain and bodies change considerably, as we all know, as we get older, and these ripples change a great deal in that they oscillate at much slower frequencies. So they're one of the fastest oscillations you have in the brain, and they decrease considerably in the old rats. So in young rats, they're at least 150 times a second. They really have this really fast wiggle. That wiggle slows down to around 130 times a second in aging. So that's one very clear effect we observed. So like everything, you might say, yeah, of course, aging, everything gets slower. I can attest to that. Yeah, true. But also you get fewer ripples. There are less of them in this case, older rats. The purple means the older animals. This is the ripples, kind of the number of ripples you get per minute, or in this case, second, in the young and old rats before they have a spatial learning experience. But then after the experience, you can see the purple bars are a little bit lower than the green, which means that they had fewer ripples that night than the young animals. So we get less of them. And this is despite the fact that by all appearances, those animals were conked out. They seemed pretty tired, but they were having fewer of these ripple events. And now getting back to the core question that I kind of started this talk with, is how do neurons coordinate their activity with one another to support things like learning and memory formation? Let me back up a bit. So to figure that out, let's zoom in. Let's just zoom in really close into one of these super fast ripple events that's occurring in your hippocampus as you sleep, or if you're dozing off to my talk, they're occurring right now. So you have these little ripple oscillations. If you zoom in on one and blow it up and imagine this blue line here, this kind of sinusoidal little line here is a ripple oscillation, and the little vertical ticks are the action potentials or spikes of an individual neuron, we can look and measure how precisely the activities of individual cells are aligned to, let's say, the peak or the trough of each of the cycles of this oscillation. And that measurement can give us an indication of how precisely timed the neurons are to the ripple oscillation. And then we can compare old and young rats. And sure enough, the old rats have a lower level of precision with respect to the ripple oscillation than the young. So they're not as precisely timed. And similarly, if you look at the kind of the time between adjacent spikes of an individual cell and how reliably a neuron, let's say, fires with an interval, like a given interval from one spike to the next, that reliability at which the neurons fire at regular intervals with one another can be quantified in this thing called an interspike interval histogram. I won't go into all the details of that. But what this plot shows is that for really short intervals between adjacent spikes or action potentials, you get more precision, more reliability at those small intervals in the young rats than the old, which goes on to say that perhaps that could account or contribute to this spike timing dependent plasticity that occurs in the brain during sleep and waking, where you need to have precision and timing between the presynaptic neuron or this pre-neuron A and post-neuron in order to enhance the connection between two cells. And so jitter or adding noise to that system, which might be happening in age, could affect negatively the ability to form those connections. And this precision question may not just apply to aging, and not just apply to sleep. More recently, as of yesterday, I did analysis yesterday to address this question. So this is hot off the scientists' press. So we scientists get all excited about this stuff. I decided to look at waking oscillations and the degree to which neurons organize their activity to a waking oscillation called the gamma rhythm. So when rats run around, here's a rat running on a record player. I don't know why he's running on a record player, but he's really good at it. And during the waking behavior, rats run and you generate different oscillations that correlate with the speed that they're running, with the amount of inputs they're getting from the external world, visual input. And these higher frequency oscillations called gamma oscillations, 40 to 100 hertz, correlate with the speed of an animal running and how much they're processing information, how quickly and how efficiently they're processing information. At least that's what we think they're doing in the hippocampus. And what this plot shows is what the individual neurons, how well they phase lock, just like that previous plot, how individual neurons in the young and the old rats reliably activate at a particular cycle of these oscillations. And you see more reliability in the young rats, suggesting that they're more precise in time, also in waking. So again, it's saying that our brains are perhaps less precise in the timing of the action potentials as we get older. Okay, so with that, I'll just end with some takeaways. So maybe some of you out there haven't heard of ripples before, but now you've been introduced. So you've heard of these fascinating oscillations, super brief, again, only 70 milliseconds long or so, that occur in all of us as we sleep, well, again, as you're dozing off during the day. And they're incredibly critical for memory formation and memory consolidation. And they really do this while we're asleep. So we get their work for free. In aging, we have reduced slow wave sleep, both in quantity and quality. We have fewer ripples, and most of the oscillations that we've measured in the brain slow down. And the degree to which the individual cells in our brain, the neurons, organize their activity precisely to the timing of the oscillation gets disrupted in aging. And so we're looking carefully into that to see what the impact this might be on memory performance. In the future, we really want to also investigate how this is disrupted in pathology. So how is this coordination then also potentially disrupted in Alzheimer's disease, in Parkinson's disease, and in other disorders, or with different drugs? One area of research that our lab is heavily into right now is the role ketamine may play in alleviating some of the Parkinsonian symptoms, or at least some of the dyskinetic symptoms associated with taking medications you take when you have Parkinson's disease. All right, so how might this lead to treatments? Well, we could find treatments that increase the number of ripples or improve the coordination between neurons during ripple oscillations. That's a potential metric we can look for. We can try to find drugs that do that. Or hopefully, like I mentioned earlier, there is some exciting early research that needs more work since there's some failures again to replicate, but some research where maybe we can artificially, non-pharmaceutically enhance slow wave sleep and these spindle and ripple oscillations through electrical or auditory stimulation. These are neat and unique and potentially exciting routes that, if they hold up in science, could be new directions for treating any sleep disorder. All right, with that, I will just want to put this slide up to thank all the wonderful people that have contributed to this research and the funding organizations that have helped us along. And to those who made this talk happen, Dottie, Morgan, and LJ, thank you for making this whole talk happen. And with that, of course, I'll open to questions.
Dr. Cowen, thank you so much. It is astonishing, the research that you're doing, and to take the time to explain some of that to us. I know that that leaves us with many more questions, which is wonderful. That's exactly what we hope to do with these presentations. Getting some questions around sleep trackers. So there are a number of sleep trackers on the market right now. So getting some questions around Fitbits, for example. Can you talk a little bit about how well Fitbits measure sleep quality?
Well, they're very interesting, and I don't use one right now, and they're very good at recognizing when you're asleep and when you're not asleep. But they're not that great at determining what type of sleep you're in. As I mentioned before, those old rats, they looked from the surface that they were sleeping pretty well. But when you actually looked in their brains, they had fewer ripples. Their depth of sleep was actually not as good as the young rats. So I think the Fitbits do a really good job of telling you how much sleep or how much time you're inactive during night. They might not be able to tell if you're staring blankly at the ceiling or not, but they do a good job of generally giving you an overall estimate of sleep quality. But they won't tell you how much slow wave sleep you're in. They might give an estimate, but you can't really trust the estimate that much. And they don't tell you so much about how much REM sleep you're in, this kind of dream sleep. Because to really get a good estimate of REM sleep, you need to measure muscle activity. Because when in REM sleep, your muscles go super slack. And that's a super good indicator. And you also get those eye movements. So without that kind of information, you can't be that sure of what type of sleep you're in. But I'm a big fan of them in general, because they can give you good feedback as to your quality of sleep in general.
So a follow-up question on that. You talked about, the difference between the stages in sleep. One of the questions here is, I'm spending about 55 minutes each night in deep sleep. Is that good? And are there ideal amounts of time spent in each cycle? How accurate is this type of measurement? And I think you keyed in on the one, this is related to a Fitbit, but can you speak a little bit to the length of sleep and ideal amounts of sleep in each sleep cycle?
Yeah, I wish I could say there's a single answer for each individual. There is a lot of individual variation. I think we all have our different set points as to what is our maybe optimal amount of sleep. And in general, more is better. Although Dick Bootson, who was a faculty here at Arizona, had some interesting research saying too much is not a good thing either. So that there is a sweet spot for the amount of sleep you get. Whether that particular amount is ideal, I don't know, again, given that you can't really trust the estimates too much of how much true slow wave sleep you're getting from a Fitbit, it's a little hard to estimate. I'm hoping that we'll get like Fitbit version 5.0 soon, where you will get some sort of feedback as to either brain or muscle activity or eye activity, so that we get a more clear estimate as to what exact stage of sleep we're in, so we can maybe titrate things a bit. But yeah, overall, generally more is better, but the usual things about sleep hygiene apply. So try not to eat right before go to bed. Try not to have any blue lights too much before you go to bed. Try to have a regular time to go to bed. Don't drink much before going to bed. These are typical things that they're very important, and they really do help maintain and increase the amount of both slow wave and REM sleep at night.
Excellent. So we're getting some questions around the hippocampus, focus on the hippocampus, particularly as it relates to memory loss with the folks that may be on the call and particular interest there, but also the role of the hippocampus in location and navigation. The question is, I'm interested in the location navigation function of the hippocampus. Is the hippocampal function the same with bats and fish who use senses other than vision to navigate?
This is a great question. So fish, I don't know. It's hard to point to a perfect hippocampal structure in a fish, given the evolutionary distance between us. But in bats, surprisingly, I have a friend in Israel, and he's managed, this is just, I don't know how he did this, but he managed to record the activities of individual neurons in bats flying in like a 200-yard arena. And so he's actually measuring wirelessly these neurons in the hippocampus as they're flying around. And sure enough, they also respond to spaces as they're flying around. And they also respond to spaces in the bats. Bats are kind of awkward crawlers, but they do crawl around. And so you also see these spatial place fields in there. But I think the question probably also related to echolocation. And now I've got to remember, because I'm sure, bats aren't using their eyes so much for their navigation. They're using their echolocation capacity. How is the hippocampus maybe synchronizing with echolocation? That's a good question. I should reread some of this person's papers. I'm sure there's an interesting story in that, and how maybe the brain oscillations are synchronized with the echo signals to help coordinate the timing of neurons. So it's a great question. I'll have to look at, but I can give a link to that person's paper. His name is Nakamulanowski. He's does some really great work in bats.
Thanks for that. We're getting a ton of questions in, and we are a bit limited for the time that we have for Q&A, but let me ask you one more, maybe around exercise and memory consolidation. And there's a question here on exercising the brain regularly seems to affect memory, maybe reduce memory loss. Why is that, and how does it impact the brain cells and brain plasticity?
Yeah, exercise. So if there's one thing that I can be really confident about the science and medical science, is that exercise is one of the best treatments you can give for almost any disorder. I mean, at least a general health disorder, including memory and cognition. So regular exercise, staying fit, very good for improving the quality of your sleep, duration of your sleep, and the regularity of your sleep. How it does this, now that was the main question. I wish I could give a solid answer to that. I don't have a solid answer to that. There might be some, and I'm sure others perhaps even in the audience could give a better answer to that. But one, I think, important contribution of exercise is blood flow and circulation. And a lot of the issues that we have with aging, or at least a chunk of them, relates to problems with our microvasculature in our brains and our bodies. And so keeping our blood supply, our vasculature healthy and active, I think exercise helps a lot with that, to keep that blood flow and the perfusion of our tissues. So that is one. Of course, heart health and cholesterol, all these other things are improved with exercise. And I'm sure there are many more. I mean, you get a lot of like endorphins and other great things that happen with exercise that probably help with brain health and mood, that also improve and reduce stress. But yeah, I'm not an expert in exercise, but I think that all those things are contributors to its beneficial effects on memory and cognition and health and sleep.
Final question for you. There's lots of interest in this, and the Q&A is blowing up here. If people wanted to learn more and go deeper on some of this, where would you direct them to learn more about what they heard today?
Great. Well, I put it in my PowerPoint, but I'll send it along. There's some nice review articles. Some are more broad. Some are those, like if you're really interested in some more of the technical details, I can provide those. And these are from the scientists. So they're the people who are actually in the trenches doing the research that can give a good, like the stuff, for example, that I'm interested in are these system level interactions, how the hippocampus talks to the cortex and how that talking during the evening can strengthen memories. I have a whole, there's a great review done by Jan Bjorn and some others that I can send out. And so that might be one spot. I can send you some other links too that I could provide after the lecture.
That's excellent. Well, Dr. Cowen, we thank you so much for taking the time to be with us today and present what is certainly a hot topic, something that people are very interested in. So much appreciated.
Great. And again, thanks for the invitation.
Thank you. Now, I'm pleased to announce our second presenter. Steve Tam is going to share with us the difference between what we heard with Dr. Cowen and some of the age-related and healthy changes that happen in the brain related to healthy aging, sleep, and memory, and contrast that with some of the more concerning signs around risk for and development for Alzheimer's and other forms of dementia. So please, Steve, take it away.
Okay, thanks, Morgan. Let me just share my screen with you. Okay, is that okay with everyone? Well, Dr. Cowen's discussion brings back a lot of memories, as my dad would get up sometimes 5 to 10 times a night. My mom was not able to get restful sleep, and she worried about what my dad was doing when he got out of bed. Nights were very stressful for her. I volunteer in memory of my late parents, and I personally hate how Alzheimer's disease took an emotional toll on my family. The disease robbed my father of his memory, his ability to walk and talk, and to be able to communicate with my mom and even with his grandchildren. My dad passed away about 4 days before my parents' 60th wedding anniversary. This disease caused me to quit my 20-year career in real estate. Instead, I spent a lot of time as a caregiver, and then for the last 10 years, advocating for seniors and increasing awareness of Alzheimer's. When I retired last year from the Alzheimer's Association, I remained personally committed to the association and helping families affected by the disease. Today's program is designed for those who want to learn more about the warning signs of Alzheimer's and other dementias, and those who notice memory or thinking changes in themselves, in others, and or their loved ones. Let's take a look at what we're going to be discussing today. We're going to explore the most common warning signs of Alzheimer's to help you be informed about what is normal aging and what is not. Hopefully, by the end of the program today, the goal is for you to be able to describe the typical age-related memory, thinking, or behavioral changes. Recognize common warning signs of Alzheimer's and dementia. Discuss the tips for approaching someone about memory concerns. Explain the importance of early detection benefits of the diagnosis, and identify possible tests and assessments for the diagnostic process. Also, hopefully you'll be able to name the resources available through the Alzheimer's Association. Okay, as we are here to learn more about dementia and Alzheimer's and the common warning signs, you might have heard about the terms dementia and Alzheimer's, and it's used interchangeably sometimes. While they are related, there's significant differences between the two. Let's hear more about this from some Dementia and Alzheimer's Association experts. First, Dr. Heather Snyder is going to discuss what dementia is.
Dementia is the umbrella term for an individual's changes in memory, thinking, or reasoning. There are many possible causes of dementia, and Alzheimer's is the most common cause. Other causes of dementia are vascular dementia, which is marked by changes in the blood flow in the blood vessels of the brain. Dementia with Lewy body, identified by specific brain changes throughout the brain that include the buildup of a protein known as alpha-synuclein, and frontal temporal dementia, which is marked by brain cell loss in the front sections of the brain or the frontal lobe. Each type of dementia may have distinct characteristics to cause specific behaviors in the individual, but there is also some overlap in behaviors among the types of dementia.
Alzheimer's is the most common form of dementia, accounting for more than 80% of all cases. Next, Dr. Dean Hartley is going to explain to us what the disease is and what it looks like in the brain.
More than 100 years ago, Dr. Paula Gogin described specific changes in the brain, what we call the formation of the plaques and tangles. Now, Alzheimer's is a progressive brain disease that's marked by these changes and is thought to impact memory, thinking, and behavior. The brain has three main parts: the cerebrum, the cerebellum, and the brainstem. Each one plays a role in how the body functions. The cerebrum, built up mostly for cells, is part of the brain most involved in remembering, problem solving, thinking, and even feeling. There are about 100 billion nerve cells or neurons throughout the brain that transmit messages in order for us to create memories, feelings, and thoughts. Alzheimer's disease causes nerve cells to die, which leads to the brain tissue loss, or what we call shrinkage, and causes loss of function and communication between cells. These changes can cause the symptoms of Alzheimer's disease, such as memory loss, problems with thinking, planning, behavioral issues, and even at the end stages, problems with swallowing.
Lastly, we'll hear from Ruth Drew, the Director of Information and Support Services at the Alzheimer's Association. She's going to be talking about the importance of recognizing the warning signs of Alzheimer's.
Steve, I'm sorry for interrupting. Before you play the next video, can you see if you can adjust the volume on your actual computer? The audio is coming through very low for our participants.
Okay, one moment, please.
Sorry about that, everybody.
Sure.
It's important to know what the warning signs of Alzheimer's are and to be on the lookout. We know that we change over time, and the warning signs of Alzheimer's can be warning signs of a number of things, but when you see those in yourself or in someone you care about, it's important to check it out, to consult with a doctor, to find out what you're dealing with.
As Ruth said, it's important to know the warning signs and what they are and be on the lookout for them. The Alzheimer's Association, as a leader in this area, developed a list of 10 warning signs to help people understand the difference between normal aging and common signs of possible dementia. The list is intended to be a tool to help identify unusual changes in a person's memory, thinking, or behavior. It's important to note that this list does not constitute a diagnosis of Alzheimer's or dementia. These are simply the most common examples of changes experienced. Individuals may experience one or more of these signs in different degrees. Let's explore each sign and what some typical age-related changes may be. Okay, number one is memory loss that disrupts daily life. One of the most common signs of Alzheimer's, especially early on, is forgetting recently learned information. Others include forgetting important dates or events, repeatedly asking the same questions and increasingly relying on memory aids or leaning on others for things and tasks once handled on their own. A typical age-related change is sometimes forgetting information but remembering later. The second sign is challenges in planning or solving problems. Some people may experience new difficulties in executive functioning, including developing and following a plan or difficulty concentrating. However, a typical age-related change is making occasional errors when managing bills or household finances. Third sign is difficulty. Difficulty completing familiar tasks. People living with dementia often find it hard to complete daily tasks that used to be managed with ease, such as driving to a familiar place, writing a grocery list, or remembering how to play a favorite game. Conversely, a typical age-related change would be occasionally needing help for use with a microwave or a remote. This could also include having trouble with new technology that the person hasn't had the opportunity to engage with as frequently. The fourth sign, confusion with time or place. An individual living with Alzheimer's or another dementia may lose track of dates, seasons, or the passage of time. They may have trouble understanding something if it's not currently happening, or become confused about where they are or how they got there. This can become more dramatic or profound in the middle and late stages. A more typical age-related change could be getting confused about what day it is or when a scheduled appointment is, but figuring it out later. Fifth sign, trouble understanding visual images and spatial relationships. Some individuals with Alzheimer's or another dementia may experience vision problems, which can lead to difficulty with balance, trouble reading, and problems judging distances and determining color and contrast. This can impact driving or navigating, the surroundings around them. Vision changes, such as cataracts, they're a more typical age-related change. This sign shows us that these changes are not just about memory. It's important to think about what all the changes are and that someone's daily life may be impacted by any of these changes. Sixth sign, new problems with words and speaking or writing. Individuals may have trouble following or joining a conversation, stop in the middle of a conversation and forget what they're talking about or repeat themselves. They might also struggle with finding the right word or calling things by the wrong name. They may start using more descriptive terms to talk about something rather than the name of the actual item. A normal age-related change, however, would be occasionally having trouble finding the right word. A seventh sign, misplacing things and losing the ability to retrace steps. This sign often causes concern in people. I want to clarify that this is not about just losing your keys on occasion. Misplacing things from time to time, but retracing steps to find them, is a normal age-related change. A person with Alzheimer's, however, may lose things and not be able to recall when it was last seen or identify the location where it was placed. Or he or she may put things in unusual places, like maybe shoes in the refrigerator. Because of the lack of this type of executive functioning and awareness, a person may grow increasingly suspicious of others and start accusing others of stealing and doing so more frequently over time. The eighth sign, decreased or poor judgment. Individuals may experience changes in judgment or decision-making, such as using poor judgment when dealing with with money, or paying less attention to hygiene and grooming. This can be especially common in individuals who live alone. Making a bad decision once in a while, such as forgetting to change your car oil, that's more oftentimes a typical age-related change. Ninth sign, withdrawal from work or social activities. As we age, it's normal to feel uninterested by family or social engagement some of the times. However, someone who's experiencing dementia-related changes may start to lose their ability to hold or follow a conversation and as a result, may begin withdrawing from social encounters or hobbies. They may lose a confidence to engage in that way. A 10th sign, changes in mood and personality. Individuals with Alzheimer's or another dementia may become confused, maybe suspicious, depressed, fearful, or anxious. They might get easily upset, either at home or when they're out of their comfort zone. As we age, however, it's normal to develop very specific ways of doing things and become upset or irritable when our routine is disrupted. Someone with Alzheimer's or dementia, they may become fearful, angry, or easily frustrated, which is something that should be addressed. Okay, 1 second. Okay, our next topic is early detection. It's key that we pay attention to what's going on with our cognitive health and not dismiss any changes that we may be experiencing as normal aging, as well as that of others around us. Any change that's unusual for your level of functioning or that of someone around you is cause for concern. Many times, friends and family are the first to notice changes in someone's memory, behavior, or abilities. What I wanted to discuss now is why it's critical to address any observed changes and seek answers from a medical professional. Sometimes the person exhibiting symptoms isn't aware or may not have the insight to know, what they're experiencing, which is why having an outside perspective is critical. This is especially important for individuals who live alone or are far from friends and family. Let's listen as Dr. Salloway discusses this, and then hear from a care partner who was the first to notice changes in her husband.
It's a very interesting phenomenon that people who have memory problems are often less aware of it than family members or their friends who know them well. One of the reasons for that is our ability to monitor ourselves, which is an important part of brain function, decreases when we start having memory problems. Not in everybody, but commonly, and more than half the people with memory problems. And so the person is just not keeping track of the trouble they're having day to day. But the family members are, paying attention. If they're paying attention, they see, boy, this is starting to happen a lot, and the person's not aware of it. So the family's more aware, and they may talk to their loved one about it, and they say, I've noticed you've been repeating yourself. And they say, I'm not repeating myself. And that could either be due to the fact that they're not aware of it, or they may not want to acknowledge it.
I was all adamant about what was happening to Daryl. I wasn't sure. I didn't know. And this wasn't the person that I know. This wasn't the person. Daryl was my husband was very, he always had to be building or designing or working with his hands. And it was getting to the point where he wasn't, and he was becoming very frustrated when he was forgetting to do things or go places.
If you continue to observe these changes, it's critical that you plan to take the next step. Have a conversation with the person or close to him or her about what you've noticed. This can be difficult or an uncomfortable conversation to have. The Alzheimer's Association has developed what we call a roadmap of 10 helpful steps to help us make addressing memory concerns less daunting and more productive. Let's take a look. First, we start by assessing the situation. What changes in memory or thinking or behavior do you see? What is the person doing or not doing that's causing the problem? What else is going on? Various conditions can cause changes in memory, thinking, and behavior. Are there other health or lifestyle issues that could be contributing to these changes? Maybe it's stress, diabetes, changes in medication. Learn about the signs and the benefits of early diagnosis. You've already taken the very important first step by joining us for this program. Did you notice any of these signs in the person you're concerned about? Has anyone else noticed the changes that you observed? Talk with friends and family. What, if any, changes have they noticed? Next, prepare to have that conversation. Who should be the one to discuss concerns with the person? It could be you, a trusted family member or friend, or a combination. It's usually best to speak one-on-one so that the person doesn't feel threatened or ambushed. But use what you know about the person to judge what approach might work best. When and where should the conversation be held? It's important to have the conversation as soon as possible. In addition to identifying a date and time, you should also consider whether the person, where they're going to feel the most comfortable. What will you or the person having the conversation say? You may want to come up with something of a script. Consider, the following type of questions. Hey, Dad, I noticed you're not doing your daily crossword puzzles anymore. Is everything okay? Or maybe it's, how have you been feeling? How have you been feeling lately? You don't seem like you're yourself these days. You should also offer to go with the person to the doctor. Ask the person to see a doctor and offer to accompany them. It helps to use encouraging words, such as maybe, there are lots of things that could be causing this. Let's see if the doctor can help us figure out what's going on. Or maybe it's, the sooner we know what's causing these problems, the sooner we can address it. Or maybe say, I think it would give us both peace of mind if we talk to a doctor. If needed, it could be more than one conversation is necessary. Please don't be discouraged if that first conversation is not as successful as you'd hope. Take some notes about how it went so you can prepare for that next conversation. Please don't dismiss the changes you've noticed simply because the person is reluctant to address them or the conversation didn't go as planned. Next, reach out for support. I encourage you to turn to the Alzheimer's Association. Call their free 24/7 helpline to talk with master's level clinicians who can provide reliable support and information, including about how to have this important conversation. Finally, see a doctor. Most people address concerns about memory, thinking, and behavior with their primary care physician first. However, in some cases, that PCP may refer the person to a specialist or for further evaluation. Examples of specialists include geriatricians, neurologists, neuropsychologists, psychiatrists, and psychologists. We now know what signs to look for and how to approach the conversation. Now let's discuss the benefits of early detection.
There are a number of benefits in early detection of Alzheimer's. For one thing, a person is able to have a voice in what happens next. They can make plans. They can live life more on their own terms. They can also make plans for the future, financial plans, care plans. They can let people know what they want, which can be a real gift later on. It also allows time for families to make plans and to make decisions about who can do what and figure out care and those kinds of issues. Also, the treatments that are available for Alzheimer's don't cure Alzheimer's. They don't slow down the disease, but they do help with symptoms. And it seems as though they tend to work better the earlier a person is able to use those. So that can help too. Some people are interested in clinical trials. Clinical trials allow people to have access to treatments that aren't available yet. And for some people, that can be a really important thing to pursue.
Now let's take a look at what might be involved in the medical process to determine the cause of symptoms. Let's start by testing your knowledge. Here's a true or false question for you. Who here thinks that there is currently no way to diagnose Alzheimer's or dementia? Is that true or false? The answer is false. Contrary to an outdated belief that Alzheimer's diagnosis can only be made at an autopsy, there are actually a number of assessments and tests that make it possible for healthcare professionals to diagnose Alzheimer's and dementia with a high degree of certainty. However, determining the cause of dementia can sometimes be more difficult. Here we're going to explore possible steps of the diagnostic process. Keep in mind, as we review these steps, not everyone may be asked to undergo each one by their doctor. Assessments could include medical history, a physical exam, screening for depression, an interview with close companions. Tests could be lab tests, mental cognitive status tests, brain imaging. Many people wonder, do dementia-like symptoms always result in a diagnosis of Alzheimer's or another dementia? The diagnostic process will vary from person to person, depending upon an individual's specific situation and what the doctor feels is the right course of action for that person. The diagnosis may be something other than Alzheimer's or another dementia, which is why it's important to investigate the cause of the symptoms. Stigma and misconceptions about Alzheimer's, like nothing can be done, can deter some people from seeking a diagnosis. The Alzheimer's Association is in communities and cities across the country and provides direct services to individuals and families facing the disease. The association is available wherever and whenever you need reliable information and support. 3 of our key resources that can connect you to information and support include our 24/7 free helpline. That number to call is 800-272-3900, anytime, day or night, to get information and support. It provides access to highly trained and knowledgeable staff who can help with education, decision-making support, or crisis assistance and resource identification. There's master-level clinicians available around the clock to provide in-depth care consultations, free of charge care navigation services offered to families at any stage of the disease. Help is available in more than 200 languages. There's also, as a resource, our website, alz.org. Often the first stop for individuals following a diagnosis of Alzheimer's or another dementia It includes sections specifically for people living with the disease and also for caregivers. We also have a community resource finder. It's a wealth of community-based resources available in your area. It includes long-term care, community-based services, local association offices, and their offerings of programs and support services. You can visit alz.org/CRF. Okay, in my presentation, I hope you have a better understanding of the 10 warning signs of Alzheimer's. Know the next steps if you observe these signs and what happens in the diagnostic process. As you go through this journey, please remember that the Alzheimer's Association is here to help. The easiest way is to call the number 800-272-3900 or go to the website alz.org. Thanks for your attention and time. Let me turn it back to Morgan.
Thanks again, Steve, for sharing that really important information with all of us today. And we've got a number of questions that have come in the Q&A, and I want to bring in Claire Day, our Chief Programs Officer and Research Champion for the Alzheimer's Association, to help field some of these questions as well and share those questions between the two of you. So for Steve, let me ask you, can you talk a little bit about the stigma associated with Alzheimer's? How might that contribute to the denial by the person that's experiencing some of these warning signs?
Well, the stigma I experienced really affected, especially my mom, who was the caregiver for my dad. And it was something where she did not want to admit to her friends and family that my dad had Alzheimer's. It was such that when my dad passed away, people came up to me at the funeral and said, "Hey, I didn't even know your dad had Alzheimer's." It's that stigma which people are afraid to show, that there's a problem in their family and show weakness.
Thanks for that, Steve. Another question that someone may have related to maybe your own experience. Question is Alzheimer's hereditary? It runs on my dad's side of the family.
Claire, you want to answer that?
Steve, do you want me to take that one? So what we know about genetics and Alzheimer's disease is there is some genetic connection to the disease. There are genes that are associated with a higher risk of developing dementia. Specifically, when thinking about Alzheimer's disease, the APOE4 gene can certainly put you at higher risk. You can either inherit 1 or 2 copies of that from your parents. But what we also know about genetics is that it doesn't tell the whole story. So the true familial type of Alzheimer's, that highly genetic potential of developing Alzheimer's disease, is very small. Less than 5% of people have that truly genetic familial type of the disease. But we know that having certain genes can put you at higher risk. We're also learning a little bit more about some people having that it could be a higher risk for me as a white person, and maybe wouldn't be as high of a risk for someone who's Black. So we're learning more and more about what these genes actually mean and how they are playing a role, but they're not the whole story. In fact, the age is our biggest risk factor. And so we're learning more and more about what those risk factors look like and what we can be doing to decrease our risks. And that's why this was such a great topic to have, thinking about good sleep hygiene and thinking about those things that we can do to decrease risks.
Thanks for that, Claire. Another question is about signs of aggression. Why is my mother showing aggression? She hits the nurse. Could these changes in behavior be related to what some of the warning signs that we heard during your presentation, Steve?
I think it could be, I just relate back to my dad, where he oftentimes showed signs of aggression to his caregiver, and he would sometimes hit them. And so, you know, what was explained to me was that oftentimes it's because of the fact that, you know, he is not able to communicate, and oftentimes the communication is by way of some kind of physical motion or something, and because he's just getting frustrated.
Yeah, and I would just add, there is a great program specifically on understanding the challenging behaviors associated with Alzheimer's disease and dementia that we offer. And Steve made a reference to the community resource finder. If you go on to that, you can identify the programs. It's called Responding to Behaviors. I don't have the title perfect in my brain here, but it will go through all of the reasons behind some of these behaviors, why they happen, but most importantly, give you some approaches on how to better interact with the person living with dementia so that you can potentially avoid some of those situations.
Excellent. And maybe time for just one or two more. I heard the current drugs, such as Namenda and Aricept, don't really help as far as change the disease itself, and they come with side effects. Are there any effective treatments at this time?
Steve, do you want me to take that one?
Yeah, go ahead.
Okay. So yeah, so the current medications that are available are to treat essentially the symptoms. There are two types of medications. There's a type of medication that's aimed at treating symptoms and preventing the breakdown of a chemical messenger that's important for learning called acetylcholine. There's a second type of medication called Namenda. It's a little bit different. It regulates the activity of glutamate, which is a chemical involved in information processing, storage, and retrieval. And so these are prescribed to treat these symptoms. They're not prescribed to improve memory. They're not going to make you remember things that you couldn't remember years ago. There are some side effects that come with these medications. So, you know, people living with dementia and families have to weigh the side effects versus the potential benefit of these. And like every medication, they work in some people and they don't work in others. The challenge with these medications compared to others, if I have high blood pressure, and my doctor puts me on a high blood pressure medication, he or she can have me back in their office in a few weeks, take my blood pressure, and actually see whether or not the medication is working. With these medications, we don't see that. We don't know where the person would have been without these medications. And so it does become a really challenging thing for families to have to think about. Definitely a conversation you want to have with your physician and really figure out whether or not it's the right decision for you, given that some of them can come with side effects. Most of the biggest side effects complaints we hear, and Morgan, you probably hear this too, is some of the GI upset stomachs, some of the sort of just tolerating the medication from a GI perspective. That could be one of those big quality of life issues. You know, people don't like to have upset stomachs and be not feeling well. So you have to kind of think about what some of those things are.
Well, thank you both for fielding those really important questions, and Steve for presenting that information. I'm going to turn it back over to LJ to close us out and talk a little bit about how to access the recording for those that missed the presentation today or that want to hear it again.
Thank you, Morgan, and thank you to our presenters, Dr. Cowen, Steve, and Paula, for spending time with us today, and to all of you. As Steve shared earlier, if there's anything more we can do to support you as a family caregiver, a clinician, or someone living with the disease, or if you just need more information, please reach out to us 24/7 at 1-800-272-3900 or visit our website at alz.org. Our special fundraising, friend-raising, and awareness events are coming up. So for more information, please visit the sites listed, and we hope you will join us as a longest day participant or as a walker. Stay healthy and stay safe. Aloha, and thank you for joining us. The recording will be provided by email by the end of the week. And again, if there's anything we can do for you, please know that we're here. Take care.